the CRO, cathode ray oscilloscope, the whole thing. Now, okay, so without further delay, let's start. Let's start. Okay, let's start with thermionic emission. Now, so what's thermionic emission? Thermion, term, the word term, what does that mean? Thermal. Okay, thermal means heat. So something to do with heat, thermal. Ionic, that's ion, charged particles. Okay, especially electrons. So thermal, and then we have electrons. Emission, meaning that emission emitted by heat, heating up a material. Okay, now let's say it must be a metal. 一定要 metal， 你一定要 heat metal， 因为如果你 heat insulator, what happened to the electron? The electron cannot free themselves. Okay, so you have to heat metal. So thermionic emission happens on metal. Okay, let's take one example, sodium. Sodium metal electron arrangements 2, 8, 1, right? So we got 2 electrons, and then we got the second shell, 8, 1, 2, 3, 4, 5, 6, 7, 8, and the valence shell, only 1 electrons. Okay, now different metals, they have different electron arrangement, right? Okay, when you heat the metal, what happened? When you heat the metal, the electrons, they gain energy, right? They vibrate more aggressively, right? So now, first thing you have to know is that this electron shell, actually they are not orbit. It is not the path of the electrons. Okay, many people, they think, okay, this is the path, meaning that the electron will go according to this path. No. Okay, because in reality, the electron, they can come out and then they can come back. Okay, there's no fixed path for the electron to travel. So the shell, if it's not representing the path, then what is it representing? The shell means the energy level. Okay, the higher the shell, meaning that the further you are from the nucleus, the higher the energy level. Meaning that if I compare this electron here and this electron here, they are at different shell. So the one further, the electron, this one will have a higher energy. So what happens when electron has high energy? They can break free. Okay, that's why we call it free electrons. So metals, 它们会有很多 free electrons. Free electrons, it is not moving initially. When you apply a potential, when you connect to a electric circuit, then they will move. Okay, so that's metal. Now, what happens if I heat the metal? If I heat the metal, I'm providing energy in terms of heat. So there's heat coming in. What happens is that the last atom, the last electron, that is at the outermost shell, they gain extra energy, they vibrate more aggressively, and then they can go to higher energy level. Let's say that this band is like, the energy level is 12 electron volt. Okay, energy level is measured in electron volt, right? Let's say the shell here, it is 12 electron volt. If you have another electron here, then this electron is also having the same energy level, 12 electron volt. When you hit it, then it's going to gain extra. Now it is more than 12 electron volt. So what happened? When the electron is more than 12 electron volt, then it cannot stay at the same position anymore. It has to go up. So this electron here, it cannot stay at the same position. It has to jump to a higher shell, higher energy level shell. And then if you keep on heating, then it gains energy again. It jumps to the next higher shell. Eventually, if you keep heating it, this electron, it goes further and further from the nucleus, and the force of attraction becomes very weak. Okay, now the force of attraction becomes very weak. Then what happened to the electron? The electron can escape completely, leaving the metal. Now, when I say escape, the electron can like jump out from the metal surface. It's like going into atmosphere. Okay, not still in the structure. Okay, because free electrons means that the electron, they are not bounded by the nucleus, meaning that the atom cannot hold the electron. So the electron is free to move, but that is only in the metal structure, the lattice structure. It is still inside the metal. We are talking that I completely free the electron so that the electron can escape and leave the metal. Okay, so this electron escaping, this process is called thermionic emission. Okay, so it is done by supplying heat energy and it can escape the electron. So all this thermionic emission happens in most of the metal out there. Okay, is it all metal? No, because some metal, they have different forces of attraction. Some metal, they have weaker forces of attraction. Okay, so some metal, they can emit very many electrons, they can emit many, and some metal, they can emit only a bit. Okay, but thermionic emission happens on metal. If you heat insulator, the electron, they are held by very strong forces. You keep giving it energy, you want to make the electron escape. Keep heating it, then the electron gain energy. Yes, it gain energy, but it's not sufficient. It's not sufficient. It's still attracted by the nuclear force. So if you keep heating it until the metal itself burn out, still the electron is not emitted. Okay, so that's why we don't do it in insulator. It's only in metal, not insulator, sorry, non-metal. Okay, so that is thermionic emission. How do we define it? It is a process where thermionic emission is a process of emission of electron. Let me write this down. Process of emission of electron from the surface of a heated metal. Okay, so that's why 你看那种 bulb 他们用什么 How do we produce light in the filament bulb? They take a wire, a very, very thin wire made of certain metal, tungsten usually. Okay, tungsten. They make a very thin coil, and this thin coil, they call it the filament. Okay, what happened? They connect to electricity, plus minus, and then the electricity heat up this filament. And when they heat up the filament, what happened? Thermionic emission. So the electron will be emitted from the filament. Okay, will be emitted from the filament. Why they use tungsten? Because tungsten, it has a very high resistance. Resistivity, we say. Resistivity very high, so it can give very much heat energy. When you heat it, it gives out a lot of heat energy because high resistance, high heat. Okay, and also tungsten is a metal, so that thermionic emission can happen. Okay, now a few things that affect how fast the emission happens. We call it the rate of emission. When you see rate, means how fast. Okay, rate of emission, we are really talking about the number of electrons emitted in 1 second. 在1秒里面多少个 electron give out. The more means that the higher is the rate of emission. Number 1, temperature. This is just logic, right? Higher temperature means more electron will come out. Number 2, surface area. The surface area of the metal. The larger the surface area, you heat it, more electron can be emitted. Number 3, this one is the types metal. Remember I said types of metal. Some metal, they have weak attraction forces. Some metal, they have very strong attraction forces. Okay, for example, if you take lithium. Okay, lithium, it has 2 and then 1 outside. Compared with sodium. Sodium got 3 shells, right? 2, 8, and then 1. So lithium, the valence electron is closer to the nucleus, so it will have a stronger forces compared to this one. Okay, so the types of metal affects the rate of emission. If the force is weak, then you hit it very easily, then it will come out. Okay, what else? Number 4. All this you need to remember, 1, 2, 3, 4, they will ask you one. Okay, number 4 is coating. Coating. Okay, like coated material. Okay, what coating? Now there are 2 types of coating. Barium oxide. Barium oxide. You need to remember the name also. Barium oxide and strontium oxide. Okay, now why coating will increase the rate of emission? These 2 coating, okay, their purpose is to make the metal release more electron easily. Okay, let me write this down. They will make it release, make electron release easily from the metal. If you take a metal without coating, compared to a metal, you coat it with barium oxide. It's like you apply 1 more layer coating. Then this coating one will increase the rate of emission. Okay, so why? Why? Because normal metal, right? If you only hit the metal, let's say you only hit the tungsten filament, okay, the tungsten filament without any coating, then the metal, they heat up easily, yes, but metal themselves, they has very low rate of emission. Low rate of emission. You have to put extra metal on it. Like sometimes they use this. They take the filament and then they put 1 extra metal piece on top of it. So that when the filament heats up, this filament heats up another atom. Sorry, another metal here. And usually this metal is coated with barium and strontium oxide. Okay, they all work together like a integrated system. The filament, why we don't hit the metal directly? Why we don't hit this metal directly? Because if you hit metal directly, they do not increase in temperature very fast compared to the filament. Okay, I know it's very fast. You hit metal, it's very fast, but compared to the filament, it's not as fast as the filament. Okay, so that's why they don't directly hit the metal. They hit what? They hit the filament first with electricity. And the filament will heat up faster, and then this filament will then heat up the metal on top of it. Okay, only the filament itself is not enough. You have 1 extra layer, the metal on it. And plus, this metal is also coated with barium and strontium to further increase the rate of emission. Okay, so now the question is, since these 2 coating increases the electron emission rate, right? But why don't we just directly use the strontium and barium? 为什么我不要直接用这个2个呢？还要扣它，这样麻烦。我直接用它更好，因为它 emit electron 很快嘛，对不对？ Now, answer is this. The reason why we don't use it directly is because they themselves is not a metal. Okay, so you take more time to heat up. Okay, so first one, very difficult to heat. Number 2, not only they are very difficult to heat, also they are not metal, meaning that they cannot conduct electricity. Okay, So number 3, what else? Their specific heat is very high. What is specific heat? Remember in your senior one, specific heat capacity, right? Specific heat very high, meaning that their temperature increases very slowly. If you heat it directly, their temperature increases very slowly. So you have to heat very long time. Only then the electron can come out. Okay, so 3 reasons why we don't use it directly. That's why we need a metal as a base. That metal as a base, and then we put the coating on top of it. Because the metal can heat up easily, and the metal can give out electron, plus the layer further increase the electron. What happened to the filament? The filament underneath is to heat up the metal on top. Okay, because filament, they heat up much faster than the metal. So overall, 如果你看这个 thermionic emission, overall, 它是用什么? You have the base is the filament, is made of tungsten, right? And then on top of it is a layer of metal. And then this metal is also coated. Okay, so overall, they make a whole package. Okay, so the tungsten heat up faster. The coated material increase the electron giving up. So overall, they kind of like they work together as a integrated system. Okay, so then an electron will come out. The electron come out from where? The electron come out from the metal, from this metal. And is there electron coming out from the tungsten? Yes. Electron 也是从 tungsten filament 出来，可是没有这样多。Okay, metal 出来的 electron 比较多。So the tungsten is still giving out electrons. Okay, now this is thermionic emission. Now, next one. Why do we need thermionic emission? Why do we want to emit electrons? Okay, let me go to the next slide. I erase this first. If you want to take a screenshot, you can take it now. And I go to the next slide. Okay. You should be able to see my slide, electron gun. Okay, so electron gun works on the principle of thermionic emission. Now, at the base here, you can see cathode. Cathode is connected to the negative terminal. Okay, to the negative terminal. And it is connected to low voltage, 6 volt, about 6 volt, right? And this potential will heat up the filament, this filament. And then what happened is thermionic emission will occur, right? Then what happened? The electron will be channeled. The electron that comes out from the cathode here, they go initially, they go in all directions. They go in like scattered direction. So you need a focusing anode. This is the one. You see this anode is connected to positive charge and is connected to very, very high voltage. This EHT, EHT 是什么来的? EHT 是 extra high tension, meaning that extra high voltage. And the voltage is about a few thousand volt, 3K to 4K or above. Okay, so why do we want to connect to very high voltage? Because this anode, it accelerates the electron, it increases the speed of the electron. Okay, not only increases the speed, it focuses the electron in one very narrow beam. Very narrow beam. So the moment the electron come out, this electron will go, it will be captured. It will be captured by this anode cylinder and pass through the hollow space inside. And it will be focused like one very narrow ray, and it reaches the other end, it strikes the screen here. This beam of electrons is called cathode ray. Okay, 什么是 cathode ray? Cathode ray 不是 light 来的啊，不是光啊，不一样啊，它是 beam of electrons. Beam of electrons. So cathode ray is actually electrons. Okay, if you have many electron channel in one beam. Okay, now when the cathode ray strikes the screen, then the screen will glow green color. Okay, will glow green color. Why? Because of the fluorescence. The screen is coated. It's coated with phosphor. Okay, phosphor that changes the electron beam into light. The electron is accelerating very fast, right? By the anode, it is accelerating very fast. So it has very high kinetic energy. And when it hits the screen, this kinetic energy will convert into light energy and it will glow green color. So this is basically how the electron gun works. The electron gun, the function of the electron gun is just to produce electron, just to produce the cathode ray. That is the whole function of the electron gun. The screen, the glowing part, that one, that is another section. Okay, so this is the electron gun. The main function is to produce the cathode ray by using thermionic emission. Let's go to the next one. Now, another setup looks very similar to the electron gun. That is called the Maltese cross tube. Okay, Maltese cross tube 它是很像一个 modification. It's like a modified version of the electron gun. Okay, modified version of electron gun. Maltese cross tube 的功能是什么呢？它是用来只有一个功能，就是用来 study the deflection of the cathode ray. Okay 啊，所以如果问题问到你 ，OK， Maltese cross tube 用来做什么啊 ？Study the deflection of cathode ray. Okay, 怎样 study? Now this is the setup of Maltese cross tube. You see, it's almost very similar to the electron gun. The only difference is that you have this cross over here, right? This cross, and then you have extra circuit. Now let's say 我们有两个 switch. 第一个 switch 在这边，第二个 switch 是这边。OK， 这个 switch 是 control 这个 cathode 的，这个 switch 是我叫它 S1 啊 ，S1 是 control 的 cathode， 然后 S2 是 control 我的这个 anode。OK， when I close switch 1， 我关 switch 1的时候 ，then current pass through 这个 cathode 对吗 ？then I heat up， 它就会 release electron。可是我讲 electron 是 release in scattered direction 对吗？一来它是没有 focus 的，所以如果我不开 switch 2啊。如果我不开 switch 2， 就是I don't close this switch, it's open, no current is flowing. What happened? You will see a light on the fluorescent screen here, but it is not the light from the electron. This light you see will be yellow or orange in color. Yellow or orange in color. This is just light emitted from the filament. Because when you hit the filament, right, it gives out light also, just like a light bulb, a filament bulb. You hit it, it glows and it gives out light. So there is light coming out also, not only the electron, okay? So the light comes out, it shoots on the screen, then it will form a yellow-orange color. So when the question asks you, yellow-orange, what is it? It is actually light, not the cathode ray. Cathode ray is green color. Now that is when I open switch 2, right? What happened if I close switch 2? If I close switch 2, then electricity passes through the anode, right? It charges up the anode. This anode will become positively charged, plus, 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 plus. And it's very high voltage, 3000 volt. Okay, it becomes positively charged. And what happens is that this positive charge will attract, because positive attract, negative, it attracts the electrons. It causes the electron to focus. Now the electron, instead of going in all direction, now they become a beam if you turn on the anode. Okay, if you turn on the anode, then it becomes a beam that passes through and then it strikes the screen. What is the use of the cross? What is the use of the cross? When the electron passes through, right, it forms a shadow, because some of the electron can pass through the cross and some of the electron cannot pass through. The electron that strike the cross will go into the circuit. Okay, you can see the cross is also connected to the circuit, to the EHT circuit. So when the electron strike the cross, then it will be absorbed and go into the circuit, then comes back. The electron that passes through, then it will hit the screen, it will produce a green light because of the fluorescence, and then it will create a shadow of the cross. It will create a shadow. Now, this cross, why do we call it Maltese cross? Actually, because the scientist's name is called Maltese. So he uses Maltese cross. Actually, is you can use anything. You can use, not necessarily it has to be a cross. You can use like A, B, C, D, E, anything, okay? It's just a cross. Okay, so it's not like there's some specific reason why it must be a cross. No, you can use anything, okay? So the Maltese cross is to create the shadow. Now, the use of this whole thing, this whole setup is to study the deflection, right? So how do we study the deflection? We would take the magnet or anything, magnetic field or electric field. We put this cathode ray tube inside the magnetic field or electric field, and then we observe how is it deflected. Is it deflected up, down, left, right? We observe from the shadow of the cross. So that is the whole purpose of the Maltese cross tube. Okay, you can put, if 如果这一个是 light 的话，它这边会是什么颜色？ Orange 跟黄色，对吗？ Orange 跟黄色。然后如果你拿一个 magnet 啊，但是你拿一个 magnet， 你放靠近它，它的这个 shadow 是不会变的，还是 maintain 一样，因为 light 不会给 magnet 影响。OK， 那如果你开这个 circuit， 所以是你拿到的是 cathode ray， 不是 light， 然后你会看到的就是它这个颜色变青色。如果你拿一个 magnet 靠近它哦，会发生什么事？你会看到那个 shadow 会走掉 ，it will change position。为什么？因为 cathode ray 是 electron 来的嘛，对不对？你拿 magnet 靠近，那个 magnet 会 deflect 那个 electron。So if you put a magnet here, the magnet will deflect the electron. Okay, so this is to study the deflection. Okay, next one. Okay, so that's the first one is the electron gun, and this is the Maltese cross tube, is a modified version of the electron gun. Okay, next one. Now this one looks familiar. This one is the old TV that we used many years ago. Now we use what TV? We use all flat screen, right? Even computer also we use flat screen. 以前的那种电视厚厚 ，OK 大大个的肥肥的，这个电视就是那个 CRO 来的，它里面就是那个 electron gun。你看的这个 screen 呢 ，this screen 呢 is the screen here. This screen here, the fluorescent screen. Okay, but how come this one looks circular, right? Looks like a sphere, but the TV is like looks a bit flat, because actually there is a curve, but you cannot see. It's at the edge here. Okay, this whole thing is that it curves backwards. You're seeing this like almost flat surface is because of the electron gun is very big. Okay, so if you look at inside the TV is actually the CRO, the electron gun, the tube. The whole thing, this whole thing is the tube. The screen that you are looking at is the fluorescent screen. Okay, now let me give you another picture. This one. This is inside. Okay, you can see the tube. This is the tube. Where is the filament? Over here, this part. Okay, this is the tube. Now, and one more thing is that the CRO, this thing is vacuum inside. It is vacuum. This thing is evacuated. Okay, meaning that no air particles, no air molecules. Why? Because if it's not evacuated, if it's not vacuum, then the electron that travel at high speed, they will strike the molecule of air. When they hit the molecule of air, then they go in every direction. They got scattered. They change direction. They go everywhere. So we don't want that to happen. So we make it a vacuum inside the tube. Okay. And also the anode accelerate the electron to very high speed. Initially, the electron, once it is emitted, it is not traveling at very high speed. So the anode with very high potential, it accelerates it to a very great extent so that electron move at very high speed. Now, kinetic energy formula 是什么？ half mv square 对吗？如果你的 velocity 越高，你的 kinetic energy 越高。所以那个 electron 它 strike 那个 screen 的时候它是 strike at a very, very high speed. What happened at the screen here? There's a coating of phosphor. Okay, phosphor, and this coating, it will convert the energy. Because when the electrons strike the screen, the electron will stop completely. Energy cannot be destroyed. So the kinetic energy must have converted to some form. In this case, it is converted to heat and light. When the electron strike, it stops here, and then the energy, all the kinetic goes to heat and light. The light energy produced by the electron is very, very small. Initially, it's very small, the light. The coating, the phosphor coating, amplify the light energy. I repeat, the phosphor coating, it absorbs this small amount of light energy, and then it gives out a lot of light energy. And it happened to be in green color. Okay, why is it green? Actually, it's because of the certain material. Certain material, they absorb light, right? And they give out certain color of light. That depends on the property of the material. So it just happened to be green color. Okay, so this one, the phosphor, the screener, at the screener, it absorbs the small amount of light produced, and then it creates a lot of light energy in green color. And it will produce heat also. Now, other than phosphor coating, there's another coating that they will ask you. Okay, let me write this down. Phosphor. This is the first one. Other than phosphor, there's a second coating called the graphite. The graphite. Okay. Now you need to know also what is the function of this. The graphite coating, it is connected to the earth. Graphite is a conductor. Okay, 它是 conductor. 所以全部那种 electron 到这个 screen 它会 accumulate 在这边。所以我们不要这一个发生，我们不要太多的 electron accumulate 在那个 screen。为什么？因为如果你太多 electron accumulate 在那个 screen 时 then 你接下来来的那种 electron 他们 reach 不到那个 screen， 因为它会 build up 那个 charge 然后它会 repel 它。Okay, all these electrons, they stuck here. They will build up a potential, a negative potential. So if it becomes great enough, the electron coming, they cannot reach, they will be repelled. So we don't want that to happen. That's why we put a graphite layer, and this graphite layer, they will send all the electrons down into the ground, away. That's why it must be a conductor. Okay, so the graphite function is to prevent, write this down, prevent the accumulation of charges. The function of the phosphor, this one, convert kinetic energy into light energy. Okay, create the light energy. Okay, so that's basically what you get here. Okay, now next one. Okay, so this is the cathode ray tube. Okay, you can see inside here. Now, if you take out, then this is it. This whole thing is a cathode ray tube. Okay, now if you look inside, what's inside the cathode ray tube? It looks like this. Okay, this diagram is everywhere in your reference book, textbook. Okay, you can see this. This is how it looks. So this is basically this entire thing is basically your TV. Okay, you're seeing the screen here. Now, it's broken down into a few sections. All this you need to know. The first one, electron gun. So the back one, okay, the first section here, all this, they are the electron gun. Okay, what is the electron gun? The function is to only produce electron by thermionic emission. And then next to it, we have the deflection system, the X plate and the Y plate. And then we have the third part is the screen here. Okay, now heating element. Let's look at the first one, cathode. This is connected to the electricity supply, right? So this heating element heat up and will give out electrons. So the cathode give out the electrons. The cathode is like the metal. Okay, remember the metal is the one that give out the electrons. Okay, and then 你可以看到 the EHT, extra high tension circuit, also connect to the cathode and is a negative terminal. Why? This is to further push the electron out from the metal. Push the electron because electron is negative. So if I connect it to negative, then the negative potential will further push the electron, forcing them come out from the cathode. Okay, that's why I connect here also. When the electron comes out, they are scattered, and you can see this ring here. This is the control grid. Okay, the ring shape. This is the control grid. The control grid is to control the amount of electron passes through. Okay, control the amount of electron passes through. If you have many electron passes through, then you will get a very bright spot on the screen because many electron hit the screen, more energy. So by controlling the amount of electron that passes through, I control the brightness. Okay, so remember the control grid is to control what? Control the brightness of the spot over here. Okay, the next one you can see is focusing anode. Okay, focusing means that it focuses the electron, right? When the electron goes through the control grid, it goes like this. Okay, I'm not sure if you can see my drawing. Okay, the electron goes like this. Initially it curves up, but then if you put the focusing anode, then it will curve up and it will come back down like this. Curve out and then come back down into the anode, the cylinder. Okay, so this make it narrow. The focusing anode make it narrow. And then the next one, accelerating, then it pushes at high speed. This section makes up the electron gun. The next one, Y plate and X plate. Y plate deflects the beam up and down. So the Y axis, up and down. That is controlled by the Y plate. The Y plate, how does it deflect? By applying potential. 如果我 connect 这个 Y plate 去 positive 这边下面我 connect 去 negative， then 这个上面的这个 plate 是 positive plate， 下面这个 plate 是 negative plate。positive plate 它会 attract 那个 electron， 所以 electron 一 pass through 的时候啊，它会 deflect， 向上， it will deflect like this。 By the y plate it will deflect upward. Okay, if I invert the charge, I connect here is negative, I connect down here is positive. What happened? The plate at the bottom will attract the electron, and the electron will curve downward like this. If no potential is applied to the plate, then the electron will travel straight. Okay, same with the X plate. X plate is controlling the horizontal displacement, the x-axis. OK 啊，所以你看到的那个 dot 啊，上下是 controlled by y plate， 左右是 controlled by x plate。OK， 所以你的 y plate 跟 x plate 都是有 connect 去 potential 的，有 connect 去 circuit 的，因为它要 deflect the electron beam。So basically, this is the CRO and the working principle, how it works inside. The TV you see, okay, how come we see not a bright spot and we see pictures everywhere, movement, right? It's because they actually have a few colors in the TV. They have the RGB color, red, green, blue. And with these three primary colors, they mix up, okay? They form millions of colors. That's why you see in the TV many colors, but it's all come from the combination of the RGB. Okay, but at its simplest construction, the TV is just like a cathode ray. Okay. Okay, 来我们继续啊。Now, using a cathode ray, this is the interface. This is the cathode ray oscilloscope. Okay, so this is the screen. This is very small one lah. So behind this screen is the electron gun. Okay, now you see this image very complicated. Actually, it's not. You only focus on a few things. Okay, all these cal, mag, all these you don't look at it. Okay, don't look at it. Only focus a few things. Now, I'm going to teach you here how to kind of like analyze, okay, the wave profile from a CRO. Okay, few things that you need to know. First is the intensity, focus, and okay, I do it like this. Power, switch on and off, right? This one, the second one, intensity. 看到吗？这个 INTN intense 这个是用来什么？这个是用来 control brightness. Okay, control brightness. So meaning that this one is used to control what? Is used to control the control grid. Remember the control grid? That is the control the amount of electron can pass through, right? So this is the one that controls it, the intensity. And then under it, you have the focus knob, right? This is to control the narrow, how narrow I want the beam to be. If you don't control this focus, then you get a huge beam like this. Huge beam, and then this beam is very blurry. Okay, I can focus it into a very narrow and very bright beam, very bright spot like this. This is the focus knob. And then other than these two, you have to know these two. The X pose and the Y pose. What is this two? X pose and Y pose is to shift. Okay, let's say 你一打开哦，你一打开这个 CRO， 它射去这边。OK， 它的 dot 射去这边，因为一来你不知道它是向哪里的嘛。 你一打开哦，它 electron 一射进那 screen 哦，它就会 in random direction。Okay, it can be everywhere. So let's say 你一打开它射去这边哦，这样我不要在这边哦，我要 adjust 它，我要 adjust 它从去那个 origin。我要用什么来 adjust？ 我就用这个 x pose， 还有这个 y pose。Okay, this is the x position. So I would adjust the x position to bring this thing. Why I cannot move? Wait. To bring this dot, I cannot move. Yeah. Let's see if I can move this. Okay, yeah, sorry. Okay, let's say the dot is here. I adjust the x position. Then I can bring this to here. So I'm adjusting the x position. That is adjusting the x-axis. Okay, I bring it left and right. So I can adjust it over here. And then I would use the y pose. The y, I adjust it down again, up, down. So I can bring it back to the origin, starting here. Okay, so that is the two function, the function of these two, x pose and y pose. They are called the offset. The x is the x offset, and this is the y offset. Not only you adjust dot, if let's say you turn on and you get something like this, you get like a wave. OK， 你拿到这样的东西，你打开，然后你讲 OK， 我不要它在这边，我要移它下来，从那个我要它在那个 x axis 哦 ，then 你可以 adjust 你的 x offset 还是 y offset， 你的 y offset，OK， 因为你要 adjust vertical 嘛，所以我会 adjust 这个 y pose、y offset， 然后我会可以拿 I adjust the whole thing come down。Okay, if I adjust the x, then I can move it left, right like this. That is the function of the offset button. Okay, next one. Next one is the most important, this one, time division. Okay, 这个我们叫它 time base. The time base input. Now, time base 这个是 connect 去我们的 x plate 的。记得吗？我们的 x plate 用来 deflect 什么的 ？deflect 左右啊 ，deflect the horizontal, the x coordinate. So this time base is connected to the x plate. So it controls the left and right movement. You see, there are many scale here: second, millisecond, microsecond. Okay, so let's say if I put it to 0.2 second. This is the norm. I adjust it pointing at 0.2, meaning that my time base is 0.2 second slash division. You can see the unit is time slash division. Okay, 所以是 0.2 second per division. One division 就是这个小小的格子。Okay, so 如果我 set 去 0.2 second per division， 意思说这个格子全部一个小格子是多少 ?0.2 second 多一个 0.2 second、0.2 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 second， 就很像我在 adjust 它的 scale。OK， 我在 adjust 它的 scale。I can set it at millisecond. Okay, I can set it at 5 millisecond. So if I set it as 5 millisecond per division, then each division now become very short amount of time, 5 millisecond. That's 0.005. So meaning that one box here, one tiny square is 0.005 second. Okay, so that is the time base. And the time base is connected to the X plate, right? The time base is given a voltage that is continuously changing. What do I mean by that? Okay, it looks like this. The time base control when you switch it on, we are actually applying a sawtooth voltage. You can see from here. Okay, so whenever we switch on the time base, we are actually applying a sawtooth voltage to the X plate. So we are applying this voltage to the X plate. The voltage looks like this. Okay, now initially you can see the curve go up, meaning that the voltage increases. What happens when the voltage increases? When the voltage increases, the plate will move. Okay, because more voltage, more deflection. Okay, so let's say if the dot started here, when you increase the voltage, then it will deflect more, right? Deflect more, so it will become here. It will move to the right here. And because it is connected to the X plate, so it deflects horizontally. Okay, so what happened here? You see the voltage rises. Suddenly it drops. 突然间它跌下来。Let's say 这边是2 volt， 突然间它变去 negative 2 volt。什么意思？就是意思讲，当那个 dot 啊，它从左边它去到右边的时候是，然后突然间你 apply negative 2 volt， 它就会怎样？它就会跳回去原本的地方。Okay, I repeat. So from here, it moves along the line to the right, and then suddenly it will jump back very quickly because you can see this drop in the voltage is very steep. It's very steep. 2 volt suddenly become negative 2 volt. So flip the whole thing. This one jumps back. You cannot see the dot jump back because it happened very fast. Okay, it happened very fast. So what you will see, if you turn on the time base, you will see the dot keep moving from left to right, jump back, from left to right, jump back, from left to right, jump back. Okay, so this movement is given by this sawtooth graph. It is actually voltage. Okay, so point number 2, you see, this makes the electron beam sweep across the screen at a constant speed. By knowing the period of each cycle, okay, we can then know how fast the beam is sweeping. Okay, this one is not important. Okay, what's important here? The graph is important. The graph, okay, they will ask you, what is this graph? What does it mean? Okay, it is the sawtooth voltage. It's connected to the time base. Now, if you adjust the time base to very short period of time, if you turn it to like microsecond, all that, you'll see that the dot move very fast. Okay, because one box, now the period, the timer between one tiny box is very, very small. It's very short period of time. So the dot will move very fast. In fact, if you adjust it, it moves so fast that you cannot see that it is moving. You cannot see that it's moving. So what do you see? You see a line. 你看到一条线，一条青色的线和 horizontal line like this. Actually, it is moving, but you cannot see. It moves very fast that it forms like a line. Okay, so that's the time base. Remember that. Okay, we go to the next one. Last one, this one. The one at the bottom. Okay, we already talked about the time base. You see at the bottom, we still got 2 input. 这个两个，这个，哎，看不到。This one and this one, right? This is connected to the Y plate. Okay, this and this, they are connected to the Y plate. This oscilloscope got 2 input. It's actually the same thing. Okay, just that it can allow 2 input. So this is connected to the Y plate. So it adjusts the vertical position. And you can see the unit is in volt division. That is, we call it the gain. Okay, the gain. The Y gain. G-A-I-N. GAIN. Let's say you set this, let's say我 set 这个去10 volt，OK， 10 volt， 所以意思说它是10 volt per division， 这个是我的 gain。如果我 set 去2 volt， 所以是2 volt per division， 这个也是我的 gain， 所以你要知道你的 gain 是多少。OK， 如果我 set 去10 volt per division， 意思说我的一个格子去上面是10 volt， 多一个20 volt， 30 volt。如果我 set 2 volt per division， 这样我一个格子上去就是2 volt， 4 volt and 6 volt， going down negative 2 volt， negative 4 volt。所以你其实你是在 adjust 你的 scale， 你 adjust 你的 scale， 你就是很像在 adjust 你的 graph。Let's say 你拿到的是一个 sine graph 这样子，如果我要弄那个 graph 高一点，我是不是 adjust 我的 scale？ 就很像你平时画 graph 这样子，我用小的 scale， 我的 graph 就看到比较长；我用大的 scale， 我的 graph 就看到比较短。所以我是用这个来 adjust。为什么我要 adjust？ 所以我容易做 measurement。我容易做 measurement。That is the gain. So the gain connects to the Y plate. Okay, so basically that's it for the CRO. You see all this, you no need to care about it. This is not important. All this AC, hold off, all this not important. Okay, so these are the most important is the time base. The time base, by the way, the time base, it can also be any input. Meaning that if you don't want the time base, if you don't want to switch on the time base, you can replace it with any input that you like here. Okay, it has a 1 input, and the Y gain has 2 input. Okay, so 我们讲 measure current CRO， 我们是用来 measure 什么 ？measure alternating current 对吗 ？Okay， 你讲 measure you connect into the input is connected to the Y plate. It's connect to what? The input. Let's say I want to measure the current from a battery. I connect the input into which one? The Y plate. The gain, okay? The gain. The time base I switch on. If I want to measure AC current, alternating current, okay, like alternating current in our household, the socket, I connect the input also to the Y gain, this one. When I connect it, what do I see? Straight away, I can see the traces. I can see the graph like this. Okay, how to calculate that one? We talk about in the next few slides. Okay, so in here, you just need to know what is the function of each thing. Okay, now 我们 break 3分钟先，过后我们再回来继续。Okay, go drink some water, go toilet, anything. We come back after 3 minutes. So 8:06, we continue here. OK， 来，我们继续啊。Okay, so look at the picture on the left. Direct current, meaning that when we input direct current, like batteries, okay, when we connect the battery into our CRO, we connect to where? Y plate, right? And when the time base is switched off. So if the time base is switched off, what happened to the dot? It's not moving. Okay, it's not moving. So direct current also, because direct current is not moving as well. Direct current has fixed voltage. Fixed voltage. So if it's 5 volt, then it's 5 volts. It's not the same as alternating. Alternating current, it's changing. Okay, it increase and decrease, increase and decrease. Direct current is fixed. So when you connect direct current to oscilloscope, then you can see one dot only when the time base is switched off, because it's not moving and the Y plate is deflected to only one side. So the dot is up here. Okay, so if you want to take the reading, depends on what is your gain. What is the gain? How many volt per division? So if it's 5 volt per division, so 1, 2, that's 10 volt. Then your DC is 10 volt. Okay, now same thing. If I switch on the time base, what happened? Remember, when I switch on the time base, we give a sawtooth voltage to the X plate, right? So the X plate will deflect, jump back, deflect, jump back, deflect, jump back. So it creates a line like this. It happened very fast, so we see a line. And this is also 10 volt, 10 volt. Okay, no, sorry, 10 volt overall. So 5 volt per division. 5 volt, 5 volt. So that's 10 volt. Okay, when you switch on the time base, it looks like this. Sometimes the question will ask you to draw. Okay, if the time base switch on and if it's how much voltage, they ask you to draw the line. Okay, next. This is for direct current, right? Next one, alternating current. Okay, now you see, alternating current meaning that they change, increase and decrease, increase and decrease. And the direction change also. First one, when the time base switch off. Okay, so when the time base switch off, 你会看到直线，为什么会直线？因为如果你 connect AC current to Y plate 的话 ，the vertical plate 啊，它会 change 嘛，对不对 ？AC current 会变得 increase, decrease, increase, decrease, so the plate keep moving up and down. That's why you get a line like this. Actually, the dot is moving up and down very fast because the frequency of AC current is 50 Hertz. That's very fast. Every second, it goes 50 cycle. So it goes very fast until you cannot see. That's why you only see one vertical line. If the time base is switched off, then it just stays there like this. If I switch on the time base, then the Y plate go up, down. At the same time, the X plate goes sideways. That's why you get this sinusoidal graph. Okay, it goes up, down, and to the left, right, like this. That's why you get this sine wave, the sinusoidal wave. How do we take measurement? Okay, so AC graph is changing. Which one is the correct measurement? Do we take the peak value? Do we take the lowest value or here? DC is very straightforward, right? It deflects how much you take the value, that's the voltage. For AC, how do we calculate it? We take the root mean square voltage. We write it as V and then RMS. What is VRMS? This is called the root mean square. 因为 AC 的 current 是 changing 的嘛，所以每一秒它都不同的。我们要怎样 calculate 那个它的 current 是多少呢？我们就 come up with something like we call it a root mean square. Okay, root mean square 是等于 我们拿 peak voltage VP. VP is the peak voltage divided by square root 2. This is the formula. Okay, you need to remember this. This is the formula. So whatever is the peak voltage, let's say it's 10 volt. 10 volt here, this is minus 10 volt. Okay, we take the peak voltage 10 and then we divide by square root 2, then we get the root mean square. Okay, so root mean square is the effective voltage. This is the effective voltage of AC. For AC, yeah, for AC circuit. OK， 来这边。看我的 document 啊。Okay, so here I want to draw this. Later I will give you this PDF. Okay, later I will give you this PDF and then you draw it. Now I show you first. Input on the Y plate. 这个是 connection Y plate. 然后 gain 是我的 scale. Okay, 我的 adjust 我的 gain. No input. Time base is off. No input 就是说我没有 plug in 什么去我的 Y plate. Time base 也是没有，所以它会怎样？它会像一个 dot. So this is just a dot. Okay. Now no input. 然后我打开那个 time base. So you move left and right. This will look like a line. Okay. Next one. If my input is 1.5 volt cell battery, so it's a DC. Okay, fixed 1.5. Now, how does it look? Time base off. Time base off, it will look like a dot, right? A dot. And if my gain is 0.5 volt per division, 意思是说一个个子是 0.5 volt， 所以这里是 let's say 这个是 equilibrium， 我画那个XY axis 先。So where will my dot be? 1.5, so it will be 1, 2, 3 boxes up. The dot will be here. Okay, 0.5, 0.5, 0.5. If I adjust, if I change the gain, if I change it to, let's say, 0.2 volt, then it will be much higher because now each boxes is less. So if I change the gain, it will affect the position of the dot. Now, when I switch on the time base, what happened? Again, it will go left and right. So this, okay, this is the axis. So the dot will sweep through left and right. So you will see a line at the top here. Next one. -2 volt cell reverse. Okay, -2 is on the Y plate reverse terminal. 这样子它会 deflect 下去。 So 10 volt per division, not 10, it's 1.0. So it will be 1.0, 2.0. So the dot will be down here. This is the origin. This is time-based switch off. Okay. Now, time-based switch on, it will sweep through. So you will see a line like this. And it's one, same, 1, 2 volt. Okay, let's try out the next one. You see, this one is 50 Hertz AC. So now it's AC current. 50 Hertz AC. Peak voltage is 20 volt. Time-based switch on. Okay, now, how do I draw this? First, we draw without the time base. If no time base, how does it look? Vertical, right? So you only connect the Y plate with the AC, so it goes up, down, but there's no left, right. So no time base. This will be vertical. And if you use gain is 5 volt per division, what is the peak voltage? The peak voltage is 20 volts. So means 5, 10, 15, 20. Over here, that's 20 volt. And then also to the bottom, 1, 2, 3, 4. Don't forget, it can go negative. So that is your cathode ray, like this. You will see a line, okay, like this. Okay, how about if I switch on the time base? Now, this is a little bit tricky. When I switch on the time base, what is the scale of the time base? 5 millisecond per division, meaning that 0.005 seconds per division. Okay, how do we know one wave had how much time? For example, if I draw the wave like this, what is the time from here to here? How do I know that? I need to find out that one. That is the time for one oscillation, right? 这个整个 wave 一个 wave 是一个 cycle 吗？所以 the time for one cycle, that's period. You need to find the period of the wave first to be able to draw it. So to find the period, you already got the frequency of 50. So T, the period, is equals to 1 over frequency. This is the formula. So you take 1 divided by 50. You get 0.0. 2 seconds. This is the period, meaning that it takes 0.02 seconds to make one cycle. Okay, from here to here is 0.02 seconds. 这样你要讲知道我要画多少个格子，多少个格子才是 0.02 second， 你就除掉你的 time base 咯。你的 time base 是一个格子是 0.005 嘛，对不对？我要知道有多少个格子，我就用 0.02， 我除掉 0.005， 所以 0.02 除掉 0.005 等于4，意思说是4个 division。 One cycle is 4 division。 讲话 OK 你就画。首先 peak voltage 到哪里？到这边 peak voltage 到这边，我这个是一个 reference line 罢了啊，不代表那个是 cathode ray 啊。So starting center 一个 cycle 是4个格子 OK up like this, come back like this. Okay, so 4个格子 1, 2, 3, 4, one cycle. And the peak voltage is 20 volt. 1, 2, 3, 4. Then I continue to draw like this. Okay, something like this. So this is how it looks. I erase this too. This is the graph that I have. OK 啊，首先找 period， 先知道它的 one cycle 是多少。OK， 我们 try 了一个啊 ，try 了一个。OK， one more。25 Hertz AC。Peak voltage 20，然后 time base 是5 millisecond。OK， 我们先找它的 period 先。So period 等于1 to 25。So period is 0.04 second, meaning that this is one cycle. I want to find how many boxes. Since I'm using a scale of 5 millisecond per division, I divide it. So 0.04 divide by 0.05. So it should be 0.005, right? 0.005. 8. So 8 squares. 8 squares, that's one wave. Okay, what is the peak voltage? 20. So if you are using a gain of 5 volt per division, meaning that from here, center, 5, 5, 5, 5. Over here, right? Okay, first we draw without the time base. So without the time base would be up here and down here. And then we draw a line. With the time base, okay. With the time base, then we draw 8. 1, 2, 3, 4, 5, 6, 7, 8. That's one wave. Okay, I can draw it at the center. 4 here. And then 4 at the back. Here. Okay, so I can join this. It's not very perfect, my drawing. Very hard to draw using my pad. But you get the point. Okay. From here to here is 8 boxes, 8 squares, meaning that that's 0.04 second. Okay, if you use the time base of 5 milliseconds per division. So that's our graph. Okay, 我们看 example 2. Okay, figure 4.31 shows the trace display on the screen of a CRO with the time base set to. Now your time base setting is 10 millisecond per division. MS millisecond, millisecond. Okay, what is the frequency of the wave? Now, swan frequency 等于 n over t. N is the number of cycle. 这个是 divide by the time。OK， 从哪里算？选容易的 point， 我从这边开始算到这边，多少个 cycle？ 一个、两个、三个、四个 cycle。One cycle 就是很像一个 sine graph 啊，或者它是很像一个cos graph 这样子。This is one cycle. This is also one cycle. This is also one cycle. Okay, we must return to the same position. If you started here, return to the same position. Started here, return to the same position. You started here. This is not, the first return is not go past, come back the second time. This is one cycle. Okay, so between these 2 points, how many cycles? 1, 2, 3, 4 cycles. N equals to 4. What is the time between these 2 points? How many boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squares. One division is 10 milli per second. So I times into 0.010 second. This. Equals to 0.1 second. So frequency 等于4除以 0.1 40 Hertz. This is the frequency of the wave. The input. Okay, so 每次你算 frequency 选2个点是最容易看的，最容易看 in terms of 多少个 wave 在里面，你不要去选那种难的那种啊，好像在中间那种啊。Okay, so let's try one more example 3, and the rest you do it. Okay, number 3. Okay, the figure shows a waveform display on the screen. If the control on the CRO are set at this and this. What is this? This is the gain, the Y gain. This is the time base. Find the peak voltage and the frequency of the input signal. Okay, peak voltage, very easy. We measure from the x-axis. So 1, 2, 3, 4. 4 boxes up. So if 0.5 per division, 4 times 0.5, that's 2.0 volt. That is our peak voltage. Okay, frequency. Find the frequency. Okay, frequency 等于 number of cycle 除以 time. 怎样知道 number of cycle? 你就看咯。OK， 我可以从这边拿这个 point 跟这个 point， 多少个 wave 在里面？一个、两个，2除以时间多少？一个、两个、3、4、5、6、7、8、9、10个个子。所以10个乘以我的 time base 是2 millisecond per division, so 0.002. That's 0.02 second. 除掉它。100 Hertz。可以吗？有问题吗？ B, sketch the trace display on the screen if the settings are changed to 1. Okay, if you change to, this one is like what we did just now, right? What we did just now. Okay, this one, I leave it for you to do it yourself. I will send you the PDF of this. Okay, before that, you do this first. Okay, 大家来，你们做这个第四题。For each of the waveform PQRS, determine peak voltage, root mean square, period 还有 frequency。就是说你做 P 先找全部 peak voltage, root mean square, period frequency, then you do the next one, Q and R and S. Okay, you find all of this and you send me your answer. Okay, we still have half an hour. You take the time. Everybody try it. Okay, everybody try it. You do it on a paper and then you send it to me, your answer, all of it, A to D. Okay, if you're not sure, you can ask. Okay, start now. So 做完了可以直接 send 给我。 OK， 会做吗？我修一题啊。For 如果你不会做 ，OK， 你们看这边，我修A。Let's do it for P first. Find the peak voltage. OK， 你可以看到这个下面这个0.2 volt， 然后5 ms， 那个是它的 scale 来的。0.2 volt 意思是说它的 gain 就是它的那个 y axis 的个子，一个个子是0.2 volt。5 ms 呢就是它的 x axis 的个子，一个个子是5 millisecond， 也就是0.005 second。OK， 所以那个是我们的 scale。所以你要找 peak voltage， 最上面这边，或者你拿最下面都可以，它是 symmetry 的。So 多少个个子你就量哦，从哪里量？从你的 x axis 量啊。1、2、3 3 squares, so your peak voltage is 3 times 0.2 volt. So it's 0.6 volt. That is your peak voltage. That's for A. B, root mean square voltage. So root mean square 我们用 formula VRMS 等于 peak voltage 除以 square root 2. So 0.6除以 square root 2. 0.424 volt. Okay, now next one. Next one is the period. OK， 我们先找 frequency 先，过后我们再找 period。其实你知道一个，你就可以找到另外一个了。你用那个 formula T 等于 1/f， 你知道一个，你就可以找另外一个。所以我先找 frequency 先。frequency 的 formula 是 general formula。frequency 是什么来的 ？number of oscillation 除以时间。在这个 wave 这边呢，有多少个 oscillation？ 你看，从这里 starting 这里去到这边，这个是一个 complete oscillation。OK， 所以从这边去到这边是一个 oscillation， 然后你就找咯，时间是多少？从这边到这边多少个 square？ 1、2、3、4、5， 1、2、3、4、5。They are separated by 10 squares. So 1 square is 0.005 second. So 10 square is, you find the time first. 0.005乘10 0.05 second. OK， 所以0.05 second 是从这边到这边，这个是一个 vibration， 一个 oscillation。所以 frequency 就是等于1除以 0.05。20 Hertz. This is your answer for the frequency. Period 就是1除 frequency， 所以1除20等于 0.05 second. So this is your period. Okay, A, B, C, D. Find all of it. 如果你的 graph， 尤其是 frequency 啊，你要会找怎样找 ？Let's say 你的 graph 是这样子。 如果我给你这边是8 second， 它的 frequency 是多少？你算有多少个 wave？OK， 从这里上回来，回到这边，这边是一个 wave 对吗？这边是一个 wavelength。One cycle， 然后这里呢，这个多余的这个是多少？这个是0.25 ，1 quarter。OK， 因为一个 wave 是这样子 ，1 quarter 是这样，你 imagine 你把它分成4个 part。1 2 3 4， 这一个呢就是1/4， 对吗 ？Okay， so this is just 1 quarter of the entire wave. This is one wave. So this is only 1 quarter. So that's 0.25. 所以如果我看这边有多少个 wave， 我就1加 0.25， 我有 1.25 个 wave， 1 and a quarter。Okay, 1 and a quarter. 1 and a quarter, I divide by the time. 所以 frequency 等于 n 除以时间， 1.25 除以8，多少？拿到就是0.156 0.156 Hertz. This is my frequency. Okay, this is my frequency of this wave here. 所以怎样找 frequency？ 先找多少个 wave 除以它的时间。像我们这个题目 P 这一个有多少个 wave 在这边？一个 wave 对吗？只有一个 wave， 然后我除以它的时间，那个就是 frequency， 就是20 Hertz。OK， 看第二个图呢 ，Q 这边有多少个 wave？ 这边有一点难看对吗？因为你这边到这边一半就不见了。这样你就选2个 point 是最容易看到的，哪2个 point？OK， 我选这个 point， 因为它刚刚好 touch 到那一边嘛，对不对？它从这边开始，然后我选第二个 point， 我可以选这边，这个2个 point 有多少个 wave between 它们？只有一个罢了 ，one wave。时间是多少？你就算咯，它的时间是多少？ R 呢 ？R， 我选这边跟这边 ，between 这个2个 point 有多少个 wave？ 这个是半个，因为一个是这样子嘛，你这个是半个嘛，对不对？所以你的半个 wave 就是 0.5 咯 ，0.5 除以你的时间是多少？这边你就算咯，多少个格子，然后一个格子是 microsecond。S 有多少个 wave？ 看你看哪里哦。我从这边看，如果我看到这边，我拿整个啦，有多少个？1个、2个、3个、4个，总共5个 wave， 所以我的 n 是5。时间你就找，然后你又除掉它，你就拿到 frequency。当你知道 frequency 了 ，period 就 1 over 1除 frequency， 你拿到 period。OK。Okay, so for this question, remember to submit your answer to me after the class. Okay, tomorrow you can submit also. So make sure you submit to me because I want to know whether you can do or not. Otherwise, I'm not sure whether you understand or not. Okay, so everyone, when you finish, send it to me. And we will dismiss the class. I will see you next week. you can log out.